I'm Anil Kumar. In this video, we'll discuss Signum function concepts. I'm going to touch upon the topics, first starting with the concepts of Signum function, absolute function, relation between absolute and Signum function, domain and range. Then we'll see how to graph few functions and find equivalent functions for Signum related functions, right? Now, this is a very important topic for pre-calculus. We'll actually also see a few examples, mainly in derivatives of absolute functions, how Signum functions becomes handy. Now, let's begin with the concepts of Signum functions, and then we'll take a few more. I'll add one more question here, and that is a quiz for you, which is to find, or rather graph. Signum functions could be written in short as Sign or Sgn, Sgn of sine x. Let that be a question for you at the end, where x is between, let's say, 0 to 2 pi. Okay, so we'll end with that particular question. Okay, so let's begin with the concepts of Signum function. Signum function can be written as Sgn x, where x is the argument. Now, basically, if you want to graph this function, it looks something like this. It is positive 1 if the value of x is greater than 0, and it is negative 1 if x is less than 0. If x is equal to 0, then the value is 0. So that is how we define a function y equals to Signum x. So here we have x, and that is the origin. So as a piecewise function, I could write this as equal to 1 for x greater than 0, equals to 0 for x equals to 0, and minus 1 for x less than 0. To remember, what you can do is you can say it gives you the sign. It gives you just the sign of the value, right? So sign of x. If x is greater than 0, it is positive sign, right? So it is like positive. Here we do not have any sign, so just forget about it. And this side, the sign is negative, right? So these are negative numbers. Like this is negative 1, that is positive 1. Doesn't make sense to you. Here it is positive 1, this is negative 1. So sometimes we do write Signum function as Sign also, right? Standard is Sgn x. Now, I've written absolute function here just to tell you the relation between absolute function and Signum function. That is very important. As you know, absolute function x could be written as equal to x if x is greater than 0 or equal to 0, and is minus of x when x is less than 0, right? So that is this is the absolute function. So let me write down here. We have Signum function, and this is absolute function, right? So let's say function. Okay, so that is absolute function. So if I write absolute x over x, then obviously x is not equal to 0, right? So let me write y equals to absolute x over x. Since x is in the denominator, x is not equal to 0. In that case, this function will be what? So if I divide this by x, look here. If I divide this by x, for example, do you see that? Obviously, we'll say that x is not equal to 0, right? Otherwise, you cannot divide by. What do you get? You get 1 and minus 1, right? You get 1 and minus 1. So if you do this, what you really get is this is equal to signum function, right? Signum x. Do you see this? So the basic, very important relation between signum and absolute function is, which is this point we're discussing, is that we could actually write absolute function as, let me write down here, as absolute function as x times signum function. And we could also write, because this could be either way, right? So we could also write x as absolute value of x times signum function. Now that is a huge importance in calculus and in higher level mathematics. Now this is a very important relation, right? So I hope you got the concept. I know I mixed this up, but anyway. Let's also talk about domain and range. So in general, domain, as you can see very clearly here, what is the domain of function? Domain of, we're talking about signum function, okay, is x belongs to real numbers, correct? Now, as far as the range is concerned, range, it could have only three values. Either it could be +1, 0, or -1. Is that clear? Right. So with that, I think we have touched upon these topics. We have understood what signum function is, how it is related with the absolute function, what is the relation between absolute and signum function, and we also know domain range. Now, based on this, let's take some examples. Okay. So let's move on. The very first example here is to graph signum function, signum x squared -1. I'd like you to pause the video, copy the question, solve, and then look into my suggestions. So we are given the signum function f of x equals to signum x squared -1. So what we will do here is that we'll first sketch graph for x squared -1. So let me make a rough sketch here. X squared -1, as you know, is a parabola moved 1 unit down, right? So it's a parabola moving 1 unit down. So that gives me this part, x squared -1, correct? Where these values are plus and -1, and the minimum here is -1. Perfect. So that is the graph for y equals to x squared -1. Signum function, as you know, literally tells you the sign. Perfect. So you can see from here that during this interval, which is from -1 to 1, the value is negative, and therefore signum function should be -1. So let me sketch this using this particular ink. Okay, so we'll say here it is -1. At these points, the value of x squared -1 is 0, so signum x will be 0. And on the right side of 1 and the left side of -1, as you can see, it is positive, right? So, I mean, what I mean to say is I should draw like this. I'm sorry. So I'm just drawing like this, a line. That will help you to guide, since I'm not using any graph paper. So what basically I want to draw here. Okay. So on this side, it is +1, correct? +1. Does it make sense to you, right? So that becomes the graph of this particular function, right? So what we can say is that this function is equal to +1 when absolute value of x is greater than 1. Do you see that? And it is equal to 0 when absolute value of x is equal to 1, correct? And it is equal to -1 when absolute value of x is less than 1. Do you see? So with the help of absolute function, we can, very easily define signum function. So combining signum with absolute function is of huge importance. It really helps in calculus. Okay, so I hope the concept is clear why we introduced these two things together. Now let's write down domain and range for this function. So the domain for this function, as you can see, is x belongs to real numbers, right? And the range for this function is, we have only 3 values. So always when you're talking about signum function, domain is all real numbers and the range is the 3 values, correct? So I hope that's okay. Now as a test question, what you can take here itself is, let's say y equals to signum sine x, where x belongs to real numbers. That's the domain. So I'd like you to write down graph the function, right? So let's graph this function. Graph this function, right? So let this be your test question. So let's move on and we'll take a few more examples. Now we'll talk about equivalent functions. So we have already discussed this topic. Here it will really help you to kind of reproduce what you have just learned. You can actually pause the video and write down equivalent functions for each of the following, right? So equivalent functions for each of the following. Is it okay? So the first one is f of x equals to x signum x. Then we have f of x equals to absolute value of signum x. And the third one is, we have nested signum functions. What happens? Correct? Okay. So if I take x signum x, okay, if we multiply this, then what happens? Let's remember, when we are talking about the signum function, we are saying that it is equal to you could write minus 1, 0, 1 also. When x is less than 0, then it's negative, right? When x is equal to 0, when x is greater than 0, either way, right? So signum function is minus 1, 0, 1, depending on the value of x. If x is negative, it is negative 1. If x is positive, it's positive 1. That's the whole idea. So if you multiply by x, what really happens? That is what we are going to see, right? So if I multiply by x, then the function becomes, let me multiply this. So it becomes minus x, 0 and x for x less than 0, for x equals to 0, and for x greater than 0, right? If x is less than 0, this becomes positive 1, right? Correct? Minus minus, it becomes positive 1. So you will see that literally this becomes positive x, right? And here 0 remains 0. When you multiply anything by 0 will remain 0. But if x is greater than 0, then also it's positive x. So basically it has become equal to absolute value of x. Do you see that? So you can say that x times signum x is equal to absolute value of x. Perfect. Now similarly, if you do the exercise that what is absolute value of x signum x, you will realize that absolute value of x basically is negative 1, right? So you will realize that this is actually equals to x. Correct? So I'd like you to verify. So as we discussed earlier, the very important relation is that absolute value of x over x is actually equals to x over absolute value of x, and it is equals to signum x provided x is not equal to 0. Is it okay? So that is a very, very important relation to understand. So if x is not equal to 0, you can kind of cross multiply and then write down. So this is x. Is it okay? No. The last one here is signum of signum of signum, like chain. Perfect. So let's do the last one here in the limited space, which is signum of signum x. Let me take two of them, right? So this series actually, we could also have infinite series in this. So I like you to verify this question, but I'll show you signum of signum x, S-I-S-G-N, okay. Right, so what you see here is signum is this, right? So if I do signum function for this, negative value will result into negative, right? So we have, for signum x, we have three conditions, let's say. So for this, we have three conditions, correct? Either this will be -1, 0, or 1, perfect. That is the output. And if the output is -1, in that case, what will you get? You're getting the idea, right? So if the output is -1, it will result into -1, 0 will result into 0, 1 will result into 0. So what you really get is that this series is also equals to signum x. So if we have infinite series of nested signum x, so we can write nested signum function is equivalent to signum function. That is very important, especially from some IIT JEE examination point of view, O level or plus Cambridge level. These are very important concepts to understand. So I hope that is absolutely clear, right? So now let me take up the question which we discussed earlier, which was signum sine x. Okay. So I hope you have got the concept of signum function and its relation with the absolute function and its importance in application. Perfect. We also looked into equivalent functions. Now we'll take up this particular example. We'll only restrict ourselves to 0 to 2 pi domain. As you know, the sine function could be sketched kind of like this. Instead of values, I prefer to use graph. You can see clearly that at this point, so what I will do here is that, okay, so we'll separately graph both. So let me show these important lines. So what we have here is y equals to sine x. Okay. And we'll have signum x here. Signum sine x. Okay. So as you can see here, these points are zeros, correct? So for zeros, we'll get zeros. So those will be the result, perfect, of signum sine x within 0 to 2 pi. In between, we have +1, correct? I mean positive value. Here it is negative value. So whenever the argument is positive, signum of positive value will be positive. So what you get here is +1, right? So whole, and that gives you. And here on this side, we get -1. Do you see that? So we get +1 or -1, 0 or -1, correct? Depending on the value of x. So if x is between 0 to pi, in that case it is positive, and from pi to 2 pi it is negative, right? So it becomes 0 to pi to 2 pi. Does make sense to you? So you could sketch the graph, and now you can write domain and range. Perfect. So I like you to extend this to general form, right? So x belongs to, let's say, real numbers. So use when sine x is 0, n pi, correct? So that will help you to divide the interval and write properly the signum function for sine x. So I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'll be great. I'll connect you with the derivatives of absolute functions, where we'll see again a very close net relation between signum and absolute functions. and that should really help you in many competitive exams. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. Thanks for watching and all the best.